PassRole and permission boundaries. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Permission boundaries are an advanced IAM feature that sets the maximum permissions an IAM entity can have, and understanding how they interact with PassRole is essential for implementing delegated administration and preventing privilege escalation. Permission boundaries don't grant permissions themselves, rather they define the outer limits of what permissions can be effective. When combined with PassRole, they create powerful governance mechanisms for multi-team environments. Let's examine the flowchart diagram on the slide, which shows how permission boundaries affect the PassRole operation. At the top, we have the start node representing when a user attempts to pass a role. The flow immediately branches to a decision diamond labeled user has PassRole permission. This is the first check that AWS performs, evaluating whether the user's identity-based policies include the IAM:PassRole action for the role being passed. If this check returns no, the flow follows the left path to the denied node labeled no PassRole permission, and the operation fails immediately. If the user has PassRole permission and the check returns yes, the flow continues downward to a second decision diamond labeled user has permission boundary. This diamond checks whether the user has a permission boundary attached to their IAM identity. Permission boundaries are optional, so not all users will have them. If the user does not have a permission boundary, the check returns no, and the flow proceeds along the right path directly to the allowed node labeled PassRole succeeds. This represents the standard PassRole flow without permission boundaries. However, if the user has a permission boundary attached and the check returns yes, the flow continues to a third decision diamond labeled boundary allows PassRole. This is where the permission boundary is evaluated. Even though the user's identity-based policy grants IAM:PassRole, the permission boundary must also allow IAM:PassRole for the operation to succeed. Permission boundaries act as a filter on top of identity-based policies. The effective permissions are the intersection of what the identity policy allows and what the boundary allows. If the permission boundary does not include IAM:PassRole, the boundary allows PassRole check returns no, and the flow follows the left route to the denied node labeled boundary denies PassRole. Even though the user has PassRole in their identity policy, the permission boundary prevents them from using it. If the boundary does allow PassRole and the check returns yes, the flow continues to a fourth decision diamond labeled boundary allows target role. This fourth check is crucial and often overlooked. The permission boundary doesn't just need to allow the IAM:PassRole action in general, it must allow IAM:PassRole for the specific role being passed. The resource specification in the permission boundary determines which roles can be passed. If the permission boundary allows PassRole but the resource ARN doesn't match the role being passed, the check returns no, and the flow goes to the denied node labeled boundary restricts role. If the boundary allows PassRole for the specific target role and the check returns yes, the flow finally reaches the allowed node labeled PassRole succeeds. Now let's examine the sequence diagram on the slide, which shows the interaction between different AWS components during a PassRole operation with permission boundaries. The diagram has 5 participants arranged horizontally from left to right. First is the developer user representing a user with a permission boundary attached. Second is the AWS service, which could be Lambda, EC2, or any service that accepts role assignments. Third is IAM representing the AWS Identity and Access Management Service. Fourth is the permission boundary policy, which is the policy document that defines maximum permissions. Fifth is the target role, which is the IAM role being passed to the service. The sequence begins at the top where the developer sends a request to the AWS service labeled Create Resource with role ARN. This represents an action like creating a Lambda function with an execution role or launching an EC2 instance with an instance profile. The AWS service receives this request and immediately sends a message to IAM labeled checked PassRole permission. IAM is responsible for evaluating whether the operation is authorized. IAM then communicates with the permission boundary policy, sending a message labeled evaluate identity policy and boundary. This is where the intersection logic happens. IAM retrieves both the user's identity-based policies and the permission boundary policy. The permission boundary policy responds back to IAM with a message labeled return effective permissions. The effective permissions are calculated as the intersection of what the identity policy allows and what the boundary allows. If the identity policy grants IAM:PassRole for all roles but the boundary only allows dev-** roles, the effective permission is IAM:PassRole for dev-* roles only. After calculating effective permissions, IAM evaluates whether those effective permissions include IAM:*PassRole for the specific role being passed. The diagram shows a decision point with an alt box labeled PassRole allowed in effective permissions. If the effective permissions allow the operation, IAM sends a message back to the AWS service labeled permission granted. The AWS service then proceeds to communicate with the target role, sending a message labeled assume role for service. The target role evaluates its trust policy, and if the service is allowed to assume it, the role returns temporary credentials back to the AWS service. Finally, the AWS service sends a success message back to the developer labeled resource created successfully. However, if the effective permissions do not allow PassRole for the target role, the sequence follows a different path shown in the else section of the alt box. IAM sends an error message to the AWS service labeled permission denied boundary restriction. The AWS service then returns an error to the developer labeled error cannot PassRole. The error message would typically indicate that the user is not authorized to perform IAM:*PassRole on the specified resource, though it may not explicitly mention that a permission boundary was the cause of the denial. The note at the bottom of the sequence diagram emphasizes the key point. The permission boundary acts as a maximum permission filter. Even if identity policies grant broad PassRole permissions, the boundary restricts what can actually be passed. This is the fundamental governance mechanism that permission boundaries provide. Looking at the first code example on the slide, we see a user identity policy with PassRole permission. This policy has version set to 2012-10-17 and contains a statement array with a single statement. The effect is allow, action is IAM:*PassRole, and resource uses a wildcard ARN::AWS::IAM::account number::role/*, which matches all roles in the account. This identity policy grants the user broad PassRole permissions for any role. The second code example shows a permission boundary that restricts PassRole. The structure is similar with version set to the 17th of October 2012 and a statement array. The effect is allow, action is IAM::PassRole, and resource is ARN::AWS::IAM::account number::role/dev-*, which uses a wildcard to match only roles whose names start with dev-. This permission boundary limits the user to passing only development roles, even though their identity policy allows passing any role. The effective permission is the intersection the user can pass roles, but only those matching dev-*. The third code example demonstrates creating a user with a permission boundary using the AWS command line interface. The command is AWS IAM create user with the username parameter set to developer user and the permissions boundary parameter set to ARN::AWS::IAM::account number::policy/developer boundary. The username parameter specifies the name of the IAM user being created, in this case developer user. The permissions boundary parameter is critical as it attaches the permission boundary policy at user creation time. The ARN::AWS::IAM::account number::policy/developer boundary references a customer managed policy that defines the maximum permissions this user can have. Once this boundary is attached, no matter what identity policies are attached to developer user, the effective permissions will never exceed what developer boundary allows. The fourth code example shows how to attach identity policies to the user. The command is AWS IAM attach user policy with username set to developer user and policy ARN set to ARN:AWS:IAM::AWS:policy/power user access. The username parameter identifies which user to attach the policy to. The policy ARN parameter specifies the AWS managed power user access policy, which grants broad permissions across many AWS services. However, because developer user has a permission boundary, the effective permissions will be the intersection of power user access and developer boundary. If power user access grants IAM PassRole for all roles but developer boundary only allows dev-star roles, the user can only pass dev-star roles despite having the broader policy attached. The table at the bottom of the slide summarizes 3 common scenarios. The first row shows a scenario where the identity policy allows PassRole for all roles using the wildcard ARN::AWS::IAM::all account number: role /*. The permission boundary allows PassRole for dev roles only using ARN::AWS::IAM::, all account number: role /dev-**, and the effective permission is PassRole for dev roles only. The intersection restricts the user to development roles. The second row shows a scenario where the identity policy allows PassRole for Lambda roles using ARN::AWS::IAM::, any account number: role /lambda-*. The permission boundary allows PassRole for all roles using the wildcard ARN::AWS::IAM::, any account number: role /*, and the effective permission is PassRole for Lambda roles only. Here the identity policy is more restrictive, so the effective permission matches the identity policy. Permission boundaries can only restrict, never expand permissions. The third row shows a scenario where the identity policy allows PassRole for all roles. The permission boundary does not include any PassRole action at all, shown as none, and the effective permission is no PassRole allowed. Even though the identity policy grants broad PassRole permissions, the absence of PassRole in the permission boundary means the user cannot pass any roles. This demonstrates that permission boundaries must explicitly allow actions for them to be effective. Thank you for your attendance. Please consider subscribing to the channel and liking this video.